Hello, everyone, and thank you for attending today's webinar, Drive Down Your Network Complexity with Advanced Automation, sponsored by Ribbon Communications. Before we begin, I want to cover a few housekeeping items. On the left-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit them to our speakers. All questions will be saved, so if we don't get to answer you, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resources List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I would now like to turn the event over to Omdia's Principal Analyst, Adora Okaliki. Adora?
Thanks so much, Regan, for the introduction, and welcome everyone to today's webinar titled Driving Down Your Network Complexity with Advanced Automation. My name is Adora Okaliki, as Regan has introduced, and I'm a Principal Analyst at Omdia's Service Provider Operations and IT Practice. I'll be co-presenting today's webinar with executives from Ribbon Communications, who are the sponsors of this webinar. But before I introduce them, let's look briefly at the agenda for the webinar. We'll start off by discussing the value proposition of AI ML-based automation and analytics in addressing CSP's business challenges. We'll take a quick overview of AI ML-based automation use cases and the benefits. And we'll also discuss the complexities associated with data modeling as a key challenge when implementing AI and ML-based automation. My co-presenter from Ribbon Communications will then provide a deep dive into the use cases for AI and ML-based automation, addressing network issues such as network operations challenges, fraud challenges, as well as use cases that detect correlations and problem areas around network protocols and functions. We'll then wrap up the presentation looking at strategies that operators must adopt to successfully implement AI and ML-based automation. There'll be a Q&A session at the end of the presentation. Here's a quick note that we have 2 polling questions which will be delivered during the presentation to keep you, the audience, engaged throughout the presentation. I'll now move on to introduce my co-presenters for today's webinar. Chip Ball is the Vice President of Systems Engineering from Ribbon Communications. Prasanna Vijayakumar is Senior Manager, Solutions Marketing, Ribbon Communications. With that, we'll move on to the presentation. Now, we're well aware of the role that CSPs play in the digital economy. This market, which Omdia has valued at about $4.6 trillion, presents huge opportunities for CSPs. However, to tap into this opportunity, they must address several challenges, including adopting new technologies to transform services, transform network infrastructure, as well as transform the business models. They also need to meet growing customer needs and counter the growing impact of competitors on revenues and margins. These competitors include the internet communication providers, as well as newer telco entrants. Now, to tackle these challenges, CSPs must address the growing complexity and cost of running their businesses. And resolving this challenge is top on CSPs' minds. According to Omdia's 2020 ICT Enterprise Insight Survey, which involves over 400 CSP senior managers across the globe, almost 80% of respondents indicated that reducing operational cost and complexity is a very important challenge they plan to address in 2020. Now, this is particularly interesting as this challenge of increased complexity trumps the challenge to personalize customer experience, which was ranked by operators following the same survey as a top challenge for the last 3 years. Now, our view is that CSPs realize that to provide personalized customer experience, they must deal with the growing complications associated with managing their networks. Now, the growing complexity in CSPs networks is driven by several factors, including the rising consumption of data services and the evolution of the network. Now, as at March 2020, data services accounted for more than 60% of CSPs revenues, growing from about 45% in March 2018. Now, this growth has led to a surge in network traffic, as Omdia estimates that network traffic in 2019 almost doubled the volume recorded in 2017 and is expected to grow to 3 times its volume recorded in 2019 by 2024. Now, the consumption of video services is a key contributor to this growth in network traffic. Video traffic alone accounted for 76% of overall network traffic in 2019, with video streaming services outweighing traffic generated from video downloads. We're not forgetting the impact of the global pandemic on businesses, where people are working from home and using more of video services to carry out their businesses. Voice traffic, on the other hand, is also increasing, albeit at a much slower rate. Communications traffic, which includes voice over LTE traffic, grew almost twice the volume in 2019 compared to 2017. And is expected to triple in 2024 as more voice traffic is carried on 4G and 5G networks. Now the increase in the type of network infrastructure and the structure of this infrastructure is another factor driving the network complexity. As CSPs prepare to implement 5G, they are prioritizing investments in network function, virtualization, and software-defined networking. Omdia Telecom's vendor contracts and analytics tool indicates that CSPs are investing more in telco cloud and software capabilities. Now, while these capabilities are being implemented to address the inflexibility and the lack of agility in rolling out new services and value to customers, the dynamic behavior of cloud-based network functions, particularly virtual machine-based network functions, adds more complexity to the network. Managing this telco cloud environment involves multiple layers and requires proactive monitoring functions as the state of virtualized network functions change very quickly. And this makes operations such as fault management, performance management, difficult to achieve. We also see that as CSPs evolve to 5G, they require denser network environments with more cells, particularly small cells, being a part of the network. And all of these add to the increased complexity within the network. Now, the growth in network traffic and the number of components and devices within the network yields even further challenges for CSPs. First, meeting service level agreements and quality of experience requirements has become very difficult, particularly for services with high latency, speed and capacity requirements. Services such as video services are highly intolerant of high latency high latency challenges within the network. Now, there's also reduced visibility into the network and service performance, as well as customer behavior. Now, this limited visibility impacts CSP's operational efficiencies in rolling out new services and addressing network incidents such as failures and security breaches. Now, underlining all of these challenges is increased operational costs that CSPs must face to address these challenges, the challenges I just highlighted. And Omdia's research shows that over 60% of CSP's revenues is spent on operational expenditure alone, a large proportion of which goes to managing network operations. So in view of this current business and operational challenges, CSPs must adopt new practices and strategies for managing their networks and operations. And the key capability CSPs plan to invest in is automation. Most CSP operations are disjointed and oftentimes manually operated, relying on humans to execute this task. Now, with network complexity growing at a much faster rate than what human skills and resources can address, it becomes critical that CSPs utilize automation techniques to drive more agility within their operations, and also reduce costs. The objective of automation is to provide a simplified approach to managing networks by utilizing technologies that augment human expertise to handle routine and repeatable tasks, all with a view to driving maximum productivity and minimizing waste and costs as well. There are several benefits to adopting automation beyond cost and enhanced efficiencies, and these benefits include faster time to market and improved customer experience. And operators get to enjoy these benefits because they can execute operations at a much faster pace and at higher quality. But automation is not new to CSPs. They have adopted several ways to implement automation, including script-based automation as well as business process automation. But the challenge with this approach is in scaling automation using these capabilities, as they are driven by fixed rules and policies that have been developed by humans. As a result, they are limited in terms of how quickly they can scale to support new scenarios in highly complex network environments, which is the case for 5G and virtualized network environments. These networks have a diverse scope for automation use cases with stringent latency and reliability requirements. So to get maximum benefits from automation, CSPs need to adopt data-driven approach to automating network operations. This approach isn't reliant on human expertise, but on data generated from the network, and so can scale to support any network scenarios. Analytics tool will play an important role in enabling this approach, providing the insights that trigger automated workflows. However, most of these tools are also driven by predefined rules and thresholds set by humans. So operators can adopt AI-based systems which presents a more effective approach to automating their networks and operations. These systems use various techniques to replicate human learning and reasoning capabilities in machines. And machine learning is one of such techniques which utilizes data to generate its learning. Machine learning models are trained to detect patterns in data sets, and based on these patterns, they can determine what is currently happening within the network or predict what could potentially happen in the network. And based on these insights and learnings, they can provide recommendations on rules and policies that can then trigger automated workflows. Now, these AI-based systems can utilize their continuous learning capabilities to optimize the rules as conditions within the network environment changes. But it must be emphasized that human supervision will be required to ensure that decisions taken by these systems align with standard practices. AI's learning predictive and prescriptive capabilities have found multiple applications within the CSP environment, and this spans both customer, network, security, and business operations. Several CSPs across the globe are already either through commercial deployments or through proof of concepts, implementing use cases, taking this approach. Telefonica, for example, is utilizing AI to support customer and network operations, as well as creating new service offerings. Its Aura platform is an AI-driven digital assistant which automates and personalizes engagement with customers. Other operators like Orange and Deutsche Telecoms are examples of operators that are also taking a similar approach to automating how they engage with their customers. From a network operations perspective, we have AT&T, Elisa, and NTT Docomo as examples of operators that are leveraging the learning capabilities of AI-based tools to automate how they manage their networks. AT&T, for example, has been very vocal about how it's been utilizing AI to predict the likelihood of network failures occurring within the network, and using these insights to trigger automated remedial actions to ensure that network failures do not impact on customer experiences. Elisa, a Finnish-based operator, is quite exemplary in its approach towards network operations. The operator runs a fully automated network operations center, leveraging AI to address issues such as reducing energy consumption. BT and Orange are examples of operators that are also utilizing AI-based automation approach to address the security issues that they experience within their networks. With fraudsters, for example, developing highly sophisticated techniques to traffic voice data internationally, Orange designed tools using AI techniques to detect fraud with a high degree of precision. Orionis is the name of Orange's ML-based fraud detection system, which is used by its wholesale and international networks division to support activities within this business. And the outcome of this solution is the reduction in the time to detect fraud, as well as improving customer satisfaction and also deriving cost savings. The group in its recent annual results indicated that they made a savings of about 40 million euros by using this solution. Now, looking at all of these examples, we see how an AI-based automation approach enables operators to become a lot more proactive, thereby, generating better services for their customers. But with how interesting and useful AI-based automation is, there are challenges within the current CSP operating environment that will make it difficult and challenging to implement this technology. And this has to do with data. Data is at the core of any AI-based system. It is used to train AI models to perform specific tasks. It, however, needs to be easily available and provided in a format that would facilitate training or learning. Unfortunately, within the CSP environment, access to relevant data sets is a challenge, and the quality of these data sets remains a huge challenge as well for operators. And this is because data is collected from a multi-vendor environment with equipment coming from multiple vendors with varying data structures and are generated via proprietary interfaces. Devices collecting these data sets do so at different times with varying granularity and with different data models. There is also continuous changes occurring within the network, which impacts on the quality of the data. Now, with these factors, the speed of development of the AI models or machine learning models that are then used to power this AI-based systems will then take time. This is because time will be spent in preparing the data sets. The training process will also be delayed as they'll be working with inconsistent data sets, which will result in more time taken to train the model. And as a result, the outcome of these AI-based systems are likely to be inconsistent with what is required within a live network environment. So it is therefore important that AI-based automation solutions that are implemented within the CSP environment address these data modeling issues and therefore speed up the rollout of the technology. I will take a pause at this point for us to take our first polling question. And our first question says, request that you select your top three challenges you expect to encounter as you implement AI and ML-based automation within your networks. The options we have are as follows: lack of expertise, for example, the data science skills, poor quality of and access to data. Number 3, the siloed approach of the silo structure of the network. Number 4, implementing AI models within networks. Access to budget to implement AI. Having a limited understanding on current network issues AI can address. And finally, transparency of the AI-based systems. I'll give us a few seconds to think of our results and enter our results. But in the meantime, I just want to mention that Chip Ball from Ribbon Communications will be continuing the discussion on the data modeling complexity challenge. And he'll also go on into further use cases with AI and ML-based automation. So we'll just have a quick look at the results, at our results. Right. Okay, so what we currently have, says that that the top challenge most of the members of the audience today see in implementing AI and ML-based automation is in the lack of expertise for data science skills. A second challenge is the poor quality of and access to data, and that's followed by the siloed structure of the network. I think the list option picked here is transparency of AI systems. These challenges, these top 3 challenges are quite they're similar to the challenges that we pick up from operators that we interact with by virtue of our research, and it does align with what we see. Chip, what are your views on these results?
No, thanks, Adora. I completely agree. Actually, I think this is somewhat reflective of essentially we're starting off with trying to just understand the data, gather the data before we actually start making sense of the data at a larger scale in terms of from an automation perspective and really pulling insights out of it. So I do feel like some of the other challenges that are further down the path are more advanced problems that you'll tend to have. But right now we're on the doorstep of the early challenges of gathering the data and so forth. And I think, with the introduction of cloud computing, and now you've actually splintered some of the access, that rings through even more, right? So it seems very sensible, right? In everyone's journey towards, using data science. Mm-hmm.
Right. Okay. That's good. I'll hand over to you now, Chip.
Oh, well, thank you.
You're welcome.
So, just, before we kind of get into the use cases and, even the recommendations that we see, I did want to spend a little bit more time on the complexity aspects that Adora went through, because, therein lies the early challenge and really kind of understanding, why all of those speed bumps and are hit, early on. So, digging in a little deeper here, obviously we want to kind of understand, like, really how do we transform, data into insights, right? How does a machine learning model work? So you've probably heard it back and forth in terms of, you have to go through training and testing and then eventually you deploy. But, taking that, one step back, obviously we need to define what our outcomes are, right? So we need to actually understand what goals we have from maybe a business perspective, and then even getting down to a data perspective. What is the outcome? This can range from I want to classify the situation, right? Are they having a good experience or bad experience? That's a yes/no classification. Maybe you want to actually give it more stratification and maybe a score 1 through 10 in terms of how good the experience is. So it can fall into the classification world, or you can even fall into more of like a continuous spectrum of providing some continuous number or value. I want to predict where my traffic throughput will be, across the year and so forth, right? So that is maybe more of rather than classification technique, it's regression technique, right? So it really does range in terms of what you want to achieve as a goal when you're modeling, and that really drives most everything else that's going on in terms of all the blue boxes and even like coming out with the models, the eventual models. But let's dig into this in a little more detail. So in general, if we were to perform a machine learning model, we want to basically start with a set of data, and that set of data, has to certainly align with our outcome. So, and it's usually a large set of data, right? So we grab that data. We want to break it up into two pieces: a training set and a test set, and it'll become pretty apparent as I explain why. But when we take this data, it's actually raw data, right? We have to prep it, right? We have to, take out all of the noise, all of the error data, maybe even actually transform the data and align the data time-wise, as Adora was suggesting earlier, right? So that preparation of data is normally called feature engineering, and it's not limited to just making sure the data is clean. You actually may need to align the data for the types of machine learning models that you want to inject it into. So, some models actually do quite well with having nominal values, which means strings, right? Time of day is morning, afternoon or night, right? So while other models require everything to be numeric. And so you may need to actually transform your data in that form. You also, if you're going to be comparing lots of data inputs, you may need to actually normalize your data, right? I can't have certain numbers being injected into a model be on the range of 1 through 10 and others being on the range of, 1 to a billion. So there's a lot of processing that goes on in terms of the feature engineering. These things are fairly well understood, but you do need to process the data for every new data set that you're coming in that form. Once you get past that point, then you can push that feature engineered data into various models. And normally you select many models based on your outcome. You have, a whole box of tools that you can use there. And you run through the models. And, this is kind of a looping process, right? Once you have the model, you look at the outcome. And, the only way we can grade this when we're looking at this training and test set is, for the most part, we normally end up taking in data that already has the answers. And, getting into that in a little more detail, it's called supervised learning. So the data that we collect during the training and test phase already has the answers and the outcomes. And so we can now take a portion of the data, say 80% of it, run it through a number of models and see how it performs with those answers in terms of the ground truth of what we're expecting. We can then test that same model with a set of data itself that, we take the labels away, or we take the ground truths away, and we run that through the model as well and see, where that lands. So, between the training process to kind of build the model and the test process to validate the model, we work through iterations there. And if we don't get it right, we have to revert back and, maybe bring in more data set, or maybe clean up some of the feature engineered data, and so forth. And normally this testing and training process, the goal is that you want to make sure you have enough data that you're covering the superset of all problems that could occur. So if I have a tiny pinhole worth of data, I'm really never going to train a model that will actually align with the real world. So that's the assumptions, and like the first two paths across the top there is that we want to have good data, clean data, data that lines with the model, and enough visibility to cover all real world cases. And once we get comfortable with that, we've gone through a validation process, then we actually look to deploy. And then in the deployment process, now we're actually taking in real world data, unlabeled data, or we don't know the ground truths, and we're just looking to get the outcome. Now, the outcome can be in the form of, we're predicting, or we're maybe even just analyzing the data, and we're doing descriptive, analytics, right? And so, but all of this is in terms of the outcome is trying to make sense of the data in that form. And this can be, an offline training and test approach, and then online deployment. Or it can be maybe a continuous process where you've blended together this training and test and deploy so that you're constantly bringing in new data to use as a test and training cycle. And then you're deploying new models, as the data sets evolve there. And this usually works well when you have data that comes in that eventually you do know the ground truth answer. Eventually that answer comes along, right? As an example, like maybe if my calls are either successful or they drop, when I'm using my phone, eventually I know that. But now I can actually look backwards and maybe predict, what are the onsets of that. So that's just one example of being able to get the ground truth data on the fly and use that. So beyond actually looking at the model complexities there, we can then dig into what is the data that we're bringing in. And here, as an example, I am reviewing VoLTE as a VoLTE application, VoLTE performance monitoring. We've moved from a circuit switch world to IP-based world, and trying to run voice over a data network or the internet can be pretty challenging, right? So you want to have good visibility there. So if that's our core insight, then we may bring in things such as SIP and RTP and get down to really protocol level stuff, and even pull in performance monitoring and fault monitoring statistics along those lines. But in reality, it's sitting on a fairly complex network. So we may need to even pull in other data. So as we pull together a model, we may end up realizing I need more data than just what I was expecting with my core insight. So I may pull from the radio access network or the packet core, or IMS core, and so forth. I may end up having to go to individual network elements, right? It really does drive up the complexity there in terms of how you're going to produce a model and the level of insight that you'll get. If I don't go to these, auxiliary data sets, then maybe if I'm trying to produce a fault management system or a root cause analysis system, I'm not going to necessarily ever get the right answer. I may actually get a pointer saying, oh, it looks like it may be in your radio network, but I can't get any further than that. And that's why you need to pull in these other data sets as one example. So in order to manage that, then you need to start actually processing the data in a more efficient way. And this can mean stitching some of the visibility that these auxiliary data sets give you without actually pulling all of the heavy load of all of the events that are going on there. So that in itself, in terms of bringing the models together and bringing the right data sets together, can be quite challenging, and really does create a bit of a data explosion. And then if we're looking at the model and we're looking at the data, we can now see that we can use this data to solve lots of different problems and challenges. And the nice thing is, as Dora was saying, we've been actually doing automation in some form or fashion in service provider networks for years, right? So we've been doing traffic engineering and fault analysis and performance and monitoring and so forth. So a lot of these techniques here that we can see where automation can apply, and in a machine learning setting, we've been doing them over the years in a more manual way, right? So that's great in the sense that we already know our problems. It's not the same as like trying to basically put vision into a self-driving car, right? We have a head start here, is what I'm saying. So, when I look down this list here and kind of go back to the outcomes, a lot of these tend to end up focusing on classification, right? So if I wanted to understand, is the network congested or not, right? Or what type of traffic is it, right? Traffic classification, is this a voice, video, within video, is it streaming or full download and so forth, right? So you can see that a lot of these end up being more classification-based problems that we're solving. But then we do see other ones here, right? Traffic prediction. I want to understand the growth of the network. Maybe I have to do some time series forecasting, right? So it does range in terms of how we end up, prepping and managing the data. And then every time we take on a new application inside of one of these areas, we really do have to follow that full cycle that we started with in terms of modeling. So really what this is, showing is that, this is an exponential complex problem here, right? We have a lot of data coming in that we're pushing through many models, so there's a factor there where we're iterating several times for modeling, and then as the data changes, we have to revisit that. The data itself is constantly changing, right? As we transform the networks from physical networks to virtual networks and leverage the cloud, we're now having to grab different data from different sources and it's from different vendors, and we have to align all of that as well. And then as we want to engage with continuing on the path for automation, we want to keep on tackling like these new and interesting areas, right? And use and leverage automation to our advantage for running the networks, which means that, that we'll grow that list of applications, continuously. So it's a multiplying effect between these categories of model, data, and problem space. It basically, pushes us to realize, we need good framework in place, right, to be able to take all the data in, manipulate and process the data, and then push the data out for actionable results. So with a little bit of that background, and it'd be good to dig into some use cases here. And before we get into that, the outcome approach in terms of what we're going after, this can be fit into different perspectives. So I wanted to at least set the stage a little here. So I've noted down to modeling network, modeling subscriber. But we can do lots of different models, right? We can bring in management data from running the network and try to model along those lines. With the advent of cloud, we may bring in all the resource details there, and same thing on the services side of the house, right? But if I dig into maybe modeling the network, right, we want to use network data to really gather and gain some insights, right? So this can be, growth or the quality of the network, right? It can range, right? In reality, a lot of these things have been in place for a while, so we want to go beyond just doing what maybe a traditional EMS, NMS, or OSS is doing in terms of measuring and showing you, where things are landing. So in reality, because we have a power of a machine learning model, I can take any networking inputs and then decide, what do I want to train that to? So as an example, I can bring in a lot of data that's describing, the fine-grained metrics of how things are performing, as services or the network is running, and I can have that trained against the end user's ground truth, how the application performed, right? So if I can get data that says videos failed, calls dropped, and so on and so forth, downloading an application, took 3 times as long. Knowing that information, I can now train a model of the input to what happened on the output side, and then use that as a technique to say, okay, I'm saying that the network is having a problem when applications are having a problem. Once I learn that, I can deploy it, and I don't need to measure the applications anymore. I just measure the network, and the network is telling me that it's predicting that the applications are having an issue. So that's an example of we're using more of the power of the data to, to drive insights versus just measuring and looking at the data. Another example, if we look at the subscriber side or the end user, again, we can maybe take all the measurements, they made calls and they did all of these things, but we may want to actually gather further insight, right? What is their overall experience if we have to sum it all up, right? And, maybe a net promoter score. So we may actually put it in a form that's more for a marketing team than a networking team. Or we may want to understand just the behavioral patterns, right? If we can personalize the network for your behavioral patterns, then maybe you will have a better experience. So here it ends up being, measuring the network to classify, understand, and baseline. And we can use that to even realize, when there's a problem, when you're doing something that doesn't seem to be normal. And that may actually mean that someone's, using your number, fraud or otherwise, right? So it really can range, but these are just a couple of examples of how to use the data. So now that we have that perspective and that understanding in terms of how we want to transform either network data or subscriber data, let's look at some examples here. So if I wanted to manage, peak traffic within the network, but I can't really do that. It's not really a time of day aspect in terms of a diurnal pattern. Everybody wakes up and checks their phone. At lunch they check and so forth, and then on the commuting. Instead, you may actually have scenarios that are a lot more fine-grained here. But with, the ability to model the network, I could come up with models that determine congestion. And then upon determining congestion, I might be able to tie that to certain actions in terms of maybe managing the network resources better at that time, right? So this right here could be, a congestion management type use case where we realize when the network is congested, maybe I'm not allowing full video downloads, or maybe I'm actually changing the encoding for the videos that are being downloaded at that time, right? So this is an example of an on-demand learning that the network is congested and having a problem, but then applying, saying, therefore, users must be having a problem, and let me actually tie actions to that. So we can take that same model in terms of understanding the congestion in the network and applying it to maybe a different scenario here, right? So, if we looked at wanting to manage a venue, managing that venue is not the same as managing, subway trains coming back and forth, right? The frequency of which a venue is actually having congestion issues are at much broader timescales there. And then therefore, you may have a lot more planning or, even like sinking in resources to be able to handle that. But you also can use all of this data in itself to essentially have a multifaceted optimization solution. So in addition to managing the congestion that may occur during, a venue scenario, we can also ahead of time, realize, can we actually do better traffic planning? Can we, get the schedules of the venue and realize whether we can on demand pull resources to cover the congestion or the onset of congestion ahead of time. So this allows us to do more traffic planning, more traffic management proactively, and then manage congestion afterwards. So moving from the network to maybe a more subscriber perspective, right? We all look at our bars and trying to understand, how good is our connection? What's the quality of our service, right? So we can build models that allow us to measure along these lines, right? Do I have good quality of service, or do I have a poor quality of service connection? And again, I can take maybe radio level data and just do a straightforward mapping there. And that's not, machine learning or prediction or so forth. But if I want to tie this to some sort of outcome of, how happy the user is, right? Maybe I tie quality of service with quality of experience, or maybe they're two separate scores. But with that ability, now I can use that to do finer grained resource management. So under good quality of service, I may actually just use standard codecs, right, and allow the services to run as is. But if I realize that there's poor service, 1 bar or so forth, I may end up employing maybe a more optimized encoding algorithm there, right? So this could be AMR wideband on the left and EVS type codecs on the right-hand side. And with the advent of cloud and more centralized solutions, just given the ability that we can move compute around, now we can have centralized resources that are much more optimally used here. So if we take that a step further, understanding both the end user in terms of their quality of service, what's being delivered, or quality of experience, and tying that together with even, managing the network and how the network is performing, now we can start to realize really more complex problems, right? And with that, now we can make decisions, whether they're operationally, let me optimize the network, or even, along the lines of, revenue generating, right? Now I can provide maybe tiered services, but rather than just a standard, platinum, gold, silver type service delivery, I can actually realize how the network is performing and give that differentiated service for those willing to pay for it. And then taking that further on, if I understand the network and I understand the user and I've measured these things over a long period of time, I do realize that they're the trends that I would expect. And then when trends actually deviate, maybe I can use that as a cue to kick in other automation algorithms that may even realize, is the network running properly, and is the user doing what we would expect? And if not, maybe we actually try and classify or categorize, is this a security threat or some other anomaly and so forth, right? So then yet another example of ours, taking this data and using it in multiple ways from multiple perspectives to realize what's going on. So Ribbon Analytics and Ribbon Communications, we've been working in this area for a long period of time across a number of applications. But the challenge has always been really kind of aligning this with what the service providers are planning to do and so forth, and what the other equipment and vendors actually have in terms of data, and is it possible to even achieve some of these use cases. The good thing is, with the advent of 5G and, even a little bit earlier in terms of as compute and cloud has come more mainstream, there are a lot of standards bodies and consortiums that are actually working on this. And they're working on it from a high level. How do I end up, identifying data, taking that data, manipulating in such a way, and then producing outcomes, and then pushing those outcomes so that I can perform an action there. A lot of groups are working on this in varying forms. And there is a relationship between these where, high-level ideas and architectural frameworks are then pushed into standardization so that those things can exist. And 5G is a classic example of implementing that in such a way where we're defining interfaces that'll be available so I know I can get the data from other elements in the network in order to implement these functions. A lot of this is around the whole entire process in terms of what is required, but really doesn't get into the details of necessarily how to implement that. Though there are some, open source projects that are actually trying to look at that as well. So what are our recommendations? So obviously we have to break this down. And I think the poll question really kind of, highlighted this point is, we really need to start with visibility, right? What is the data that we have available to us? And, how can we actually bring that together in terms of across varying systems so that we have, good insight into what the network is doing. And this really is more traditional BI, right? Business intelligence first and foremost. But pulling that data together, you may have, more higher powered business intelligence than when you had it in your individual siloed solutions. So bringing in all of that data and then having a system that allows you to move agilely, right? You want to be able to expand and even contract maybe when needed, and build out new applications and really manage that rate of change that is necessarily as you're tackling these types of projects. And then from there, having a full view of an automation life cycle, right? There's a lot of complexity here in terms of what you have at your disposal from the tools perspective, all the data that exists, and then being able to manage when it's working and when it's not working, and revise and revisit that. From Ribbon's perspective, we're building out these solutions in terms of creating Ribbon Analytics as an application suite, but it's built on a platform that allows you to have that agility that you need. So obviously, as all the technologies are coming in, from the left-hand side here, IoT and 5G and internet security and so forth, there's a range of different goals and needs here. And we have to drive that all into a platform that allows us to mix and match, manage that data, process the data and transform it into insights, and then eventually push that into automation workflows so that we can integrate that in with the systems that actually need to have that level of visibility, be that policy, resource management, or even other areas within a service provider's organization. It really does center around having a very agile system that builds out the right interfaces, is built on the right technologies in terms of being able to change quickly and manage that. So these are containers and RESTful APIs and all, cloud native, all the things that you've heard of in the past. You need to have this as a solution. Only then can you actually create the feedback loop and continuously measure, model, and refine. So with that, I would say Ribbon Communications, you probably know us from Sonus and Genban in terms of being a voice and real-time communication company. But we've really expanded the portfolio over the years to include optical transport and packet networking, even down at the transport level with the acquisition of ECI. We've built out on the edge by acquiring Edgewater, as well as even expanding our analytics portfolio with the acquisition of Innova Data. So really, we have quite a breadth of products and solutions that range on delivering networking infrastructure to even managing that infrastructure over time. Thank you very much. I'll stop there, see if we had any questions roll in.
Hey, Chip. Prasanna here. So we do have quite a lot of interesting questions. Let me, kick it off with a couple of ones. We have some time here. So the first one is to Adora. So there's a question on how do you see DSPs addressing the ethical issues related to implementing AI or ML?
All right. Thanks, Prasanna, for that question. I think the question about the ethical implementation of AI, I think, comes with the need to have more transparent systems that can be probed, okay, to understand how the models work and how, what features, what data sets they're working with as a feature data sets, as Chip rightly described during his presentation, how this model works. So what are there any biases or what factors are considered? I think being able to have that level of transparency is really critical to helping address anything that has to do with the ethical use of AI, particularly in the network environment where there are highly skilled engineers that really want to understand and make sure that the systems that are being used are following the right ethics, the right approaches that need to be adopted. So I would say that is one way, and we tend to see we're seeing quite a number of operators placing a lot of focus on the ethical use of AI within their environment. Yeah.
Perfect. In following to that, in regards to data, right? You highlighted how important it is. So, what are the this is to Chip, of course. What are some of the best ways to to get those training data, Chip?
I probably highlighted it during the presentation, but I believe we do have a lot of systems that are already out there measuring KPIs in the network and really trying to understand operationally what's going on. So I think that data itself is training data, and it is ground truth data. Unfortunately, it never comes in on time to use that, but it can be used in a way that we can maybe build models that can predict what are the early onsets or indicators along those lines in terms of essentially predicting the KPI before it even occurs or before the measurements come through there. So I think that's one technique. Obviously, there's a lot of other aspects that relate to really trying to bring in ground truth data through surveys and so forth, and maybe more refined studies. You can even do things like drive tests, right? Where you're essentially trying to measure the network from maybe a user's perspective, and then tie that back into the network. Those are just some examples.
Perfect. And there are a couple of more questions just to ask here from the audience. So quite interesting. So most of the existing solutions, there was a question on most of the existing solutions, which are CSPs, internal facing, what we have highlighted, of course. So the question is, are there CSPs investing on customer-facing AI products? This is
no, that's a good question.
For all of us.
Mm-hmm. Sorry, I'll chime in here.
Yeah, go ahead.
It is a good question. It's interesting. I think from our experience, we've had customers that have taken our products where they want to create portals for their end customers, and I think it's maybe more than just customer experience, but it ranges there. An example may be where did my data go to, right? In terms of how it's being used, more of a BI function than an AI function, right? But looking at it from an AI perspective, we have customers that essentially want to build portals to allow maybe even B2B solutions have visibility into the network, right? So as an example, I could opt in to saying you can use my data and understand what I'm doing. There's been a number of service providers that entice their customers to basically allow the service provider to use their data. So we have products, given that you've met all that criteria in terms of opt-in, we have products that allow you to categorize like what consumers are doing, and then maybe even tie behavioral patterns onto that in terms of maybe I'm looking to rent a vacation home, or I want to buy a car, right? So that these techniques, in terms of understanding usage and then tying that back to intent, can then be exposed back to, say, B2B or enterprises where they can use that to maybe engage with customers. It's just one example where we're really doing something that is very insightful, and then the service provider is exposing it out.
Anything to add here, Dora?
No, I think the examples that Chip raised are very useful. I think the question said, are there operators that are doing it? I think the answer to that is yes. In addition, to what Chip said, we were seeing. I did raise examples around how operators like AT&T and Telefonica are utilizing, AI to drive better services for their customers, understanding, using the data sets, analyzing the data sets coming from the network to understand issues relating to the network, and then using those insights to take remedial steps to addressing those issues so that customer experience remains high quality services are delivered to customers. So I think that's the most I can add. Operators, yes, are using this capability and will continue to explore the use of AI-based automation to drive better customer experience.
Perfect. We do have a few other questions here, but we will probably be at the top of the hour, and we will take them down, probably offline, directly to the people who have questioned that. So appreciate. Thank you for listening, and back to Reagan.